Okay. Cool. I think I'm already live, so that's perfect. Gucci bandana. And I don't necessarily need I don't want to kind of make this a long video. I just want to kind of talk through a specific set of concepts that's going to be really important for y'all to understand. And that's really about how to collaborate using GitHub and Git. So we've already talked in different sessions about the power of Git and what it's useful for. We'll go over that in a little and kind of in some detail in a second. But I really want to talk about the power that GitHub has in allowing you to connect and collaborate with other engineers and developers across the globe, which is funny because that's exactly what this graphic is showing is the power of GitHub to connect you across the world, right? So I'm grateful for this beautiful shout outs to the GitHub design team, because yes, that's exactly what their John is doing. And before I get ahead of myself, let me make sure I plug my computer up and not have my stuff die on y'all right quick. But yeah, so I want to talk about the process of collaborating on GitHub, which is a really important skill to have as an engineer, because at the end of the day, you're probably not gonna always be working on projects alone, right? There's so much need to be working on projects that require other help from other engineers. And so learning how to use Git and GitHub is important, because that process is how you end up collaborating with engineers across teams, whether you're doing something personal or professional. So cool. So let's kind of dive into this whole process. So y'all are already kind of familiar with GitHub to a capacity. Let me just log in here. And so yeah, so we've talked about Git and GitHub before, and the whole concept is we use Git to create repositories locally on our computer, right? And those local repositories are basically keeping an up-to-date history of our code base over time, right? That's what we've talked about with Git. That's what we do locally in the terminal. Whenever I go into a terminal that is using Git, you can see you can see that a particular folder in your terminal is linked to Git by doing the ls-a. You see that, or in Windows, like the dir command to list the contents of that folder, and you can see that that .git folder is created for you. Again, that .git folder is full of all types of code as configuration to allow for your local folder to be monitored for changes over the course of you writing different code. So the purpose of that folder, the .git folder, is so that whenever you're making edits or updates to a particular folder or project, you can see things are being modified, and as things are being modified, you can add the specific files you want to keep updating, and create what we call commits, which are short snapshots, or not, I want to say short, but snapshots of the code at that particular moment in time. It's a snapshot of the files in your folder at that moment in time. So the whole purpose of Git as a tool is to make those snapshots and then store them in the form of commits, which are these very unique snapshots that take place at a certain moment in time, and are related to the specific files that are housed in that folder at that particular moment in time. With commits, we have the opportunity to leave messages that become a little bit more helpful for when we for seeing the different moments in our project's journey, I should say. So that's basically what we use Git for, right? Is creating a history of all of the files that are changing over time in our repositories, and then using that history to revert back to old changes, or to make sure that, you know, we're keeping up-to-date records of our code in case anything ever happens. And that's typically the way that you normally use Git as a personal sense, right? It's like, hey, I'm using this to personally save my work over time. And where Git connects with GitHub in those personal senses is that you can create on GitHub, as well as a number of different other platforms. I just want to make this point that GitHub is one of many platforms that do similar things. Another platform that works very similar to GitHub that you might hear about is called GitLab. GitLab is another Git source code repository host. That's basically what all of these platforms do, is they're online platforms for hosting your Git source code, which is related to the same code that we're talking about in the terminal. So GitHub is really just a tool for keeping track of all of the projects that you use Git on locally. The value of it is that it's online and it hosts multiple repositories for you so you can keep them organized. GitLab is another one. And another one that I think a lot of people use is Bitbucket, which is another tool for storing your repositories as well. So there's a number of different tools that function similar to GitHub, but the idea that behind all of these tools is that they allow you to store your repositories or your projects online. So locally, you can store your projects and keep histories and stuff like that. But the valuable thing about storing it online is now I have it saved even more onto a external server, which makes it a little bit more protected and also starts to offer up this valuable option for other people to collaborate with me on that particular repository that's stored in the cloud. So that's what makes GitHub unique than Git as a tool. Git as a tool is its own thing, lets you save your code in snapshots, go back a history, keep track of that history, et cetera, et cetera. GitHub allows you to save that project online and allow other collaborators to connect to that same project and manipulate it with you as well. So the valuable thing about GitHub starts to happen when you start thinking about collaboration and community and whatnot. So say, for instance, you are working on a project, right? And for right now, let's pretend that this project is the old project we were working on, the Favelinks project, right? So naturally, how I got started, I created a repo for that project locally, and we can see that locally, specific, I probably ran the create react app command or whatever to like create my folder structure and my files. And then because create react app creates a Git repo for me, I just came to GitHub, created a new repository, right? Did the whole new repository flow, and with the new repository flow, created a new repository, and then eventually pushed my files up to GitHub, right? So now I have, if I ran the command git remote -v, if I followed all those steps that show up on GitHub when you're creating a new repository, right? It has at some point a line that says, hey, git remote add origin. And with that remote add origin, you paste this, you put a link in there, and that link is tied to GitHub. It's a GitHub link that points to the remote repository that is gonna host your code in the cloud, right? The valuable thing now is that oops, I did not mean to open this. The valuable thing is that now that you have this connected to GitHub, you can push your code from the local Git commits to the remote Git commits. And that's where you start seeing like your ability to make changes locally in your files, and then add the commits, and then eventually push them, like I was pushing a couple days ago, some code for this particular repo and whatnot. So that's probably, if you're at this point, you might already be familiar with how to do all of that. Like get a project going, get inside of it, out of the repo to GitHub, et cetera, et cetera. The next stage of what you need to understand about Git is the collaboration aspect of Git and how we start using Git as a tool when it comes to collaboration. So there's a couple things that I want to talk about in that sense. And so first thing is, how do you start a project that you're going to end up collaborating with other people on? Well, if you know the first step is something you already know, is get a project going on GitHub, right? So you can either start it blank, or you can start it the same way we're used to, which is like have your files already kind of already defined, and then you can do your whole git add your files, and git commit -m, initial commit, or whatever you're going to do to like get your initial files together, and then eventually push so that you have files on here. But the step number one is to always have a project ready on GitHub, because you can't necessarily just collaborate just from your local machine. You need to make sure that you can allow for folks to get access to your code, right? And so the easiest way, while you could do it locally, but the easiest way is to use a tool like GitHub, GitLab, or Bitbucket, right? Online cloud provided solution. So to do it on GitHub, all you got to do is create a new remote repository on GitHub that's going to track the changes of your local project. Once you've created that repository, you can go into settings, and in the settings, you can manage the access for your project. Managing access is a permission that only the owner of the repository has. So if you made the repo, you're the one that has to make sure you manage the access for your team and add your collaborators. On GitHub and other tools, they allow for teams to create projects as well. So instead of just one owner, it could be the case that you're a part of a team, and then you might have the access to manage access depending on the permissions you got from your team. But if you're working at a company, chances are somebody else is going to be doing this process for you of managing your access to a repository. So again, you can only do this aspect of managed access on projects that you've started, or or that you're added with this correct permissions to. Either way, for the sake of working on personal projects and collaborating with others, you'll start a new repository. And once you do that, go to settings, click manage access. And then in here is where you can change a lot of the permissions and security of your repository. But the most important thing you're going to want to do for collaboration's sake is click manage access and add people. Add people is going to ask you to type in either the username, full name, or email of the person or people that you're trying to add to your project. So a best thing I normally do is just ask folks like, what's your GitHub username, or what's the email you want me to send your stuff to? And then, for instance, if I'm trying to send something to my colleague Capera, who I work with very closely, I know that his username on GitHub, he might be like, hey, my username on GitHub is Craig. Right. And I'm like, okay, cool. I found you. I can invite him to the repository very easily by just clicking his name. Right. And then add him to the repository. And adding him to the repository, he's going to get a notification on his email that lets him know, hey, so-and-so, Cam just invited you to a repository. You should accept it if you want to collaborate. And if it takes too long, it'll show me that I'm still waiting for him to be invited. I could also copy this link and then send him the link very directly as a link if that takes too long. So that's just another way to speed up that process. And yeah, as soon as he accepts the request, he'll get added as a collaborator. Now, being a collaborator gives him specific permissions to the repository. It specifically gives him read and write access to the repository. By default, everyone has read access to our repository, right? If it's public, I should say. If it's public, if you have a public repo, anyone on GitHub can just go and read your repo, which makes sense, right? You just go to GitHub, you see a lot of repos, you just click it, and then you see the code and stuff like that. That's what happens on a public repo. Everyone can read it. But by default, not everyone can write to your repo. Even if they can read your code, that doesn't mean that they can edit your code on their own, right? So if I wanted to edit some code, I need to have write access. And so the only way to get write access is to be invited to as a collaborator to the repository. So that's first thing you got to understand is you need to be a collaborator to collaborate on a repo in a read-write sense. There is another way that you can collaborate on a repository that you don't have write access to. And I'm going to talk about that in a second. But for right now, just pretend that you're adding friends or you're adding partners, colleagues onto a project that you got to work on, right? So that's step one, is make sure you add them as collaborators. After they've been added as a collaborator, that person who's now the collaborator, right? The owner of the repo probably already has some local repository connected to the remote repository if they started it in that fashion. But for everyone, the easiest way to just get started with the repo is after the person's created it and invites you as a collaborator, I would just make sure that you clone the repo. So you can clone it by copying the clone URL that pops up, and inside of your terminal, then you can you can run the command git clone with that particular URL, right? So for me, if I was to go ahead and do this, I would just, want to do this in maybe a new terminal, just to show you the idea, right? So then what I would do is like go into a specific folder. If I was, say I was cloning the repo, somebody made it, added me as a collaborator. Now I'm trying to make sure I have access to the right repo. First thing I'm going to do is go to a space where I want to save the code, maybe I somewhere safe like my desktop, and then do git clone with the URL from the particular from that particular repo, right? And then when I run that command, it's going to clone into that project, create a new folder called with that same name, so I can CD into that project now. And I'm already connected. This project now is already connected to Git. It has the right connection points for me to then just connect at work. And I have the ability now, because I particularly have write access, I'll be able to not only read the code, but I'll also be able to push changes to the code as well. So as a collaborator, that's your responsibility, is to make sure you clone the repo and you're able to properly see all the files that you need to see. If you are cloning a React project or a JavaScript project, most projects, I should say, most projects have dependencies that people don't add to GitHub because they're files that become really, really large. So for instance, in JavaScript, we normally don't put the npm that node modules online or in our version control, because the file size of that can become really big and just make things slow. So rule of thumb is to always install the dependencies you need once you've cloned a repo. So for JavaScript, in this case, the first thing that folks are going to have to do after they've cloned the repo in a JavaScript environment is make sure you run the command npm install, right? And npm install reads this package.json file and installs all of the packages that were defined in there. So chances are, if you're watching this, you're going to be doing JavaScript. So just know that that's your first step, is to make sure that you install the dependencies from Node that are stored in the package.json file, right? That just to show you what is in there. The package.json just has a list of the dependencies that you need to run your code. If you don't do the npm install and then you try to start the project, you're going to have some errors because you didn't install the right dependencies. So that's just important to know that you got to do. But yeah, once you've installed the dependencies, then you're able to start the project just by running npm start like normal, and you can treat it like normal. But the unique thing is that now your project is connected to the same remote project as the original creator of that project. So my brother Kapera, once he downloaded and cloned the repo, he would also be able to, he's now working on a repository that's connected to this remote repository that we're both connected to as collaborators. And yeah, that's how you get set up as collaborators, right? So that's the simplest thing to understand, is how to get started as collaborators. You got to add someone, and then that person has to clone the repo. Whether you're doing this on GitHub, GitLab, or Bitbucket, the process is the same. The interface is a little different in terms of how you add collaborators, but you end up each time, if you're the person that is being added, you always have to clone the repo and get access to the repo after you've cloned it. So that's the first big thing for group work, collaborative work on Git. The second thing to know about Git is that there is a specific feature of Git, not GitHub, not GitLab, not Bitbucket, but Git, the actual software framework, that is related to how repository histories are managed over time. And that concept is called branching. So the idea of a Git branch is kind of a little confusing at first. I'm not gonna admit, I'm not gonna hold y'all. It's confusing for a little bit to wrap your head around, but I think once you get a good understanding of what it's useful for, you will understand why people use Git, why branches are important in the process of creating ideas. So I'm just gonna use this crazy looking image right here. Let's see if I see a better one that kind of explains this a little bit better. Let's do it this way. This one looks simple enough. Let's see. Open this, John. Okay, so picture a scenario where you and another person are working on a project together, right? So if you really think about it, there's a need for you all to, there's going to be different moments in time where you and that other person might be working on different things, but you're working on the same project. So Git makes that process really easy to manage by using what we call branches. So a Git branch is really just as a isolated history of Git commits. Wow, that might be like literally the easiest way I've ever defined Git branches. a, Git branch is literally just isolated history of Git commits over time. So the purpose of that is that you might not want to work on the same history because now your work and that other person's work might come at odds with each other. So what becomes helpful is, okay, we might have one main history, which we might call main or master, which, you know, depending on how you start your project, your repo normally either calls it main or master, right? You could think of that as your main history or your master history, right? Off of that one history, which is here represented in green, right? You might want to create a history that represents your work, and your partner might want to create a history that represents their work, right? So to do that, we use this concept of branching, right? Which is at any point in time, no matter where in the history, you can create a branch from that particular snapshot to create your own history starting from that snapshot. So in this example, say we have two colleagues. The first person maybe created the main repo, and the main repo would have at least one commit that would be this first commit in green, right? So depending on how many commits you make before you add other people to your repo, you might have only one commit or you might have multiple commits. But the idea is that that's your main branch, right? And you can see that on GitHub, you have either one branch called master or one branch called main that is created for you, right? But with Git, we can create multiple branches. And we might have talked about this before. I think now I'm starting to remember talking a little bit about creating a branch, development, et cetera, et cetera. But the idea is you can create a branch, which is now this isolated history. And it is the case that while you're working on this isolated history, well, guess what? Well, other things can be happening over time, right? Maybe you have 3 people working on this project, and you have your work, you have someone else's work, and then somebody is just pushing the main branch along, right? You might have made your own branch that took the first bit of changes. Maybe you started a React project and your job was, hey, add some styling to some of our components, right? And so you have your first snapshot might have those components already defined, and then you made a branch so that you could start working on styling, right? And at a certain point, you finish what you need to do. So you're like, okay, I'm done. Let me push my changes from my branch into the main branch so everyone else can see it. And that's the process here of putting your branch back into the history of the main branch. And we call this process of taking one branch's content and putting it into another branch, we call that merging, M-E-R-G-I-N-G, merging. So the process of creating a branch is cool because it gives you your own little history to work off of. You don't ever have to worry about my changes messing up someone else's changes. It's literally just my history, right? But at the same time, we can keep pushing the project forward until the point comes where I might say, okay, I'm ready to put my changes back into the main branch. And somebody else might also say, hey, I have my own copy of my own history that I want to work on, a feature or something I want to work on. And once I'm done, I'm going to push back into the main branch as well, right? The most important thing to know is that as you make changes, as changes are happening on the main branch, it's important for you whenever you're getting ready to merge or getting ready to merge really, or push changes to a different branch, make sure that you pull the changes that have happened over time. So as you can see, since the point of this person that's in blue making their branch, 2 other commits to the main branch happened. So when they're getting ready to actually merge, they're going to want to actually make sure that they pull all of the changes that happen here. And that's where Git can start to feel a little confusing when you're collaborating, where you're starting to figure out like, okay, the branches are different. somebody's working on something and I want to learn what's going on. And, you know, good rule of thumb is always pull before you push. So to kind of show you this practical example, right? So say I am on the main branch right now. I'm on the main branch of this repo. And I can confirm that by doing the git status command. It'll tell me what branch I'm on. So clearly I'm on branch master, right? So I can create a new branch by running the command git checkout -b for boy, or B for branch, I should say. B as in branch, you know. Git checkout -b and the name of the branch I want to create. So I want to create a new branch called development. And so I'll just create that new branch with that command. It'll tell me I switched to a new branch called development, which is this process that you see here, this first kind of pivot, right? So I was already on the main branch master and it had a commit in there already. I had a couple commits in master already, I think. Yeah, 6 commits in master alone. But now I just branched into development. So we can call this blue history development. And following this example, now that I'm on development, right, I have the same files that this original commit had. So whenever you make a branch, it's going to create a branch from whatever branch you're currently on and whatever the last commit was from that branch. So that's important to know that your history from wherever you make a new branch will be related to wherever you wrote that command. So it's important to know, hey, this is exactly where I want to make a branch. That's the commit I want to make a branch from, et cetera, right? And now that I have my own new branch called development, I can make a bunch of changes to this project, right? That are going to relate to the branches being a little different. So for the sake of just this exercise, what I'm going to do is, oops, let me not do this on Nano. For the sake of this exercise, I'm just going to create a new file. I'm going to say dev readme.md, and I'm going to, inside of that file, I'm just going to say, hey, this is on the development branch. Save the changes and, you know, pretending like I'm making changes to the code, right? So if I did git status, clearly I'm going to see, hey, some files are different. You're going to want to make some changes. I don't know, package-log. So in this, let me just see which one. Okay, I'm on the desktop one. Okay, so now that I made these changes, right, first thing I'm going to want to do is just add the changes, commit, created a new file, and why is this tweaking on me? Git commit -m, create a new file. I don't know why that's tweaking. Okay, whatever. And then I can push. But because I'm on a new branch, right? I'm on the development branch. I have to run the command git push. And this is only the case that you have to do this whenever you make a new branch and you want to push to that branch for the first time. So I run the command git push -u for this flag for upstream. Origin, which is, remember, origin is the connection to GitHub. So I'm pushing from my local repository upstream to GitHub, right? And then the name of the branch that I want to create on GitHub. So GitHub doesn't have a development branch, right? There's only one branch in here. And so it's whenever I want GitHub to keep a record of this new branch that I'm creating, I have to run the git push with this -u flag with the name of the branch that I want it to keep a track of. So once I run this, it adds all of the files, and now you can see GitHub updates a little bit. It says development had recent pushes. So once I refresh this code, once I refresh this page, you can see that I have 2 branches now, right? I have master, I also have development. In development now, if I click on development, I can see development clearly has this other file called dev readme with the text that we wrote, right? Switching back to master, this file, dev readme, doesn't exist. So if I were to try to go to a link that says master with this file that clearly doesn't exist, I'm going to get an error. But if I go back to just the main repository in and of itself, whoops, fave links. Right, if I just go back to this repo, clearly the master branch is there, but that file is not there. It's not reflected on that branch, which is the purpose of branching, right? So this history is completely different than the original master's history, right? So if I were back in the terminal and I want to go back to another branch, I can switch branches by saying git checkout with the name of the branch that's already created that I want to check out. So master is already there. So I can run the command git checkout master to go back to the main branch. Now on this branch, right? Remember, I don't have that dev readme. That was only created on the development branch, right? So normally what's the case is that, okay, somebody else might be working on this project. They might make their own changes, right? So maybe they made a new file called main readme, or I should say master, keep it consistent. Master readme, right? And then on here, right, they might make some changes. Like let's say go this is from master. Let me just make sure that works. Okay. Right, so they might make some changes on the master branch, right? So I just basically ran a command that just edited this file and added some text in there. So if I did git status, clearly I'm different. I have some changes. So again, git add, git commit -m, adding master readme, right? And then git push. Right, because master was already connected, I could just say git push. I don't have to do the -u origin part. I could just push. It'll know to look that this master is the same master I'm talking about on GitHub. And so now clearly on the master branch, I have this new file called master readme, right? But on the dev branch, I have a completely different history. I have dev readme. There's no master readme there. So hopefully you can see the point I'm trying to make, which is that these histories are completely different. Hopefully you don't need me to make 3 more commits to prove this point. But if you rock with me and understand this concept, it's pretty powerful, right? In this example, I just added 1 file. But if you're working on a big project, you might be changing a lot of files and making commits at each step of the way. But because you're on your own branch, it's completely isolated from the rest of the code that's stored in a different history. So typically what's the case is we keep 1 branch ready for like production code, which is why we call it main or master. This is a branch that we don't want to have too much development work happening on. We'd rather keep that work on a different branch that's going to be more edited. And so we have 1 branch that kind of stays consistent and that our whole team can always use. If they get stuck or something happens and they mess up, they can always go, hey, pull a new copy from main or pull a new copy from master, and you're never got to worry about your code messing up. So long as you make commits and you save your work over time, it'll always be easy to revert back to an old version of the code before you made that mistake, right? And that's why keeping committing often and early is really important. But just to wrap up the conversation on how collaboration works, right? So remember, I first talked about branching. You take a snapshot from a particular commit and create your own history, right? But the second concept I talked about was merging. So now you're at a point where, okay, I've made all the commits I want, and I'm ready to pull my changes or push my changes into another branch. That process is what we call merging, pushing into another branch, right? So taking all the changes from one and putting it into another. So I keep clicking VS Code because of force of habit. But so now I'm on the master branch, and say I want to get the changes from that other branch and push it into this branch, this main branch, right? So the thing to know about merging is it's always going to be important to know what branch am I pulling changes from and where do I want those changes to go to, right? So on the one hand, you got to know that first thing is the branch that I want to make so in this example, right, it's not always going to be the case, but in this example, I have changes on this branch called development that I want to put into master. So in order to do that, right, I'm saying take all the changes from development and merge them into master, right? So the syntax you would use to write that in the terminal would be, first, you got to make sure you're on the branch you want to be on, right? I'm on master, meaning I'm on the green branch now. So cool. So now that I'm on that branch, I said, I want to pull the changes from this other branch into master. So in order to do that, right, the command that you normally want to use to do this is git merge, right? And then you type the name of the branch that you want to pull the changes from into the branch that you're currently on. So hopefully that makes sense. I'm on master and I'm saying merge development, which means take development, the blue, and put it back into master, which is kind of what's happening here. The blue is going back into the green. So once I run this command, once I run this command, basically now it's going to try to make some changes on my branch for me. But sometimes you're going to get this message that says, hey, I need you to create a commit message that says why this merge is necessary. So now what you're going to need to know about this is that what you're looking at when you see this screen is an editor. This right here, this whole thing is an editor that got opened up that is asking you to type a commit message, basically. It's not asking you to type anything crazy, just saying, hey, you need to leave a commit message, which is basically what we do when we say -m, right? So for those of you who may be familiar with this editor that just popped up is an inline text editor called V. And there's V and there's Vim for anyone who's familiar with Vim. Both are inline text editors, VI, and Vim are VIM. Both are inline text editors that have a kind of unique syntax and funky syntax that people aren't always used to. So whenever you see this, these are the things, these are the gems you gotta remember. First thing is, if you see Vim, right, and you are trying to make changes, right, and you're like typing and you're seeing like nothing's happening that you're expecting, the chances are that in Vim and V, you're not in edit mode. So if you're in edit mode, you can type and you can leave messages and stuff like that. If you're not in edit mode, you know, I'm typing on a keyboard, nothing's happening, right? To get into edit mode in Vim, you have to press I. I is gonna change the thing at the bottom to say insert, right? And now that it's on insert, I can actually manipulate this block and stuff. So now I can just write a simple message and say, pulling in changes, pulling in, you know, dev readme, pulling in dev readme. Simple enough, right? Now that I'm done with whatever the message is, I can press escape, right? And now I'm back in the non-edit mode, right? And then I can say colon and then Q, or colon, my fault, colon, I think it's WQ, yeah. Oh man, I always mess up. I always forget. I always forget which one it is with V and Vim. It might be X. I gotta try that again. But after you've exited the editor, if it doesn't work, what you got to do is make a commit to complete the merge. So using the editor, I'm gonna check on that, whether it's WQ. I think it might be X, and I'm just tweaking. I always get it messed up, and so chances are you're gonna get it messed up. So the best thing to do when you get into that place is just look up the V or Vim commands. And Vim is just specific for it's just a specific terminal-based editor. So let's see which one is the one I wanted to do. I wanted to save the editor. I wanted to save the file, and I wanted to write to it. I think it's WQ or something like that. Look, here it is, W. Write, save, and quit. This is the one I wanted, WQ, which I thought I did, but maybe I didn't do it the right way. But yeah, so either way, you just want to save the file and like save your commit. But if it doesn't work, it's just going to tell you, hey, you got to commit the change. So I just say git commit -m and say pulling in dev readme. Right, and clearly that makes a commit. So now I should be able to, if I do ls in here, clearly both of those readmes have been pulled in successfully. But now the thing is that if I look at GitHub on my main branch, on my master branch, right, because that's where I merged before, I clearly don't see that change reflected on GitHub. It happened locally, right, but it didn't happen. On the cloud. So the last step is, again, after you make a commit, you gotta just make sure that you push, right? So now that I've pushed, if I refresh, I'm gonna see both readmes are reflected here. So the commit collaboration process is a little janky, I'm not gonna lie. It gets hard and complicated, and you also deal with these things that are called merge conflicts, wherein if I had a particular file that was edited over, I'm not going to show you this right now for sake of time, but you're probably going to deal with this where you have one file, but then on one branch, you know, that file has one thing, and then on another branch when you pull it in, it has something completely different. And that's going to give you an error that says, hey, well, not even an error, it's like a little warning that's like, hey, there's a conflict here, I need you to reconcile it and let me know, is this really what you, which of these changes do you want to keep? So then you just kind of go through the file and say, hey, these are the changes I want to keep, and eventually you make your commit, and then you can push, and everything's good. But in general, you know, if you're working with a good Git histories and you're always pulling changes before you push them, you should be able to avoid most merge conflicts. But you know, they're kind of an inescapable reality when it comes with collaboration in Git and GitHub. So don't worry too much if they happen. Just breathe and look through the file, say, hey, what stuff do I want to keep? What stuff don't I want to keep? And you can make those changes. Or, you know, you can revert back to a version before you made that merge and, you know, fix whatever you needed to fix so that you don't have a merge conflict. And that brings me to another really important, and this is the last thing I swear, topic related to collaboration on GitHub, which is a little bit of a shortcut to avoid some of these conflicts that can come up, but also to address the point that I was making earlier about sometimes you might not have write access to a repo, but you want to still collaborate with somebody on a project, right? And so in order to do that, GitHub has a very specific tool, and some of these other platforms, GitLab, Bitbucket and stuff, have a similar process, but you can create what's called a pull request, which is essentially a means of saying to a person that owns a repo, hey, I've made some edits to your code and I'd love for you to pull them into your main repo if you think that they satisfy your requirements or whatever. And pull requests are both really dope for projects you're not a owner of, but also projects that you might also have write access to, because it kind of creates this one-step layer before you merge directly into the code. So clearly you saw from this example, I was in development, I was making changes, then I went and I literally just merged into the other branch. And you know, that almost I wouldn't say messed up, but I still had to create this file, right? And you know, maybe something else messed up or whatever. So, you know, if that goes too wrong, then maybe I'm really stuck and I don't know what happens next. In order to combat that, most times big projects, especially in big projects, you're never going to want to merge directly into a branch, right? It's almost always better to do what we call a pull request, where you say, hey, I take the changes from this code base and you say, hey, I'd love for you to merge them if everything is good, and like that, you know, you review my code and you really appreciate what's going on in there. So I just want to show you pull requests because they're just a really important tool that come up all the time professionally. And, you know, a good feeling of, you know, you as a new developer is going to your first job, working on a project with other people, making a pull request that then somebody actually merges into like production or merges into the main branch because they're like, wow, like this was a great set of code. Thank you. And now your feature that you were working on is added into the main code base. Like that's always like a rite of passage for new developers is get your first pull request pulled in. And whether that's on an open source project or on like a professional project at work, that feeling still is really cool. And so this is also where GitHub becomes super fun in a way and collaborative and really in general, right? So you can make pull requests on any repo that's public on GitHub so any repo you can see on GitHub, you can always make a pull request. And basically with a pull request is you have the opportunity to say, for instance, on, let's see if I, so one more thing to show you is if I am now on, I'm on master clearly, but master is updated and it has all of the same stuff from development. If I go to development, clearly development is update with itself, but if I ls, it doesn't have the same changes as master does. So I can also update a branch very easily by doing the command git pull and the branch I want to pull. So pulling is like pulling without specifying how to reconcile divergent branches is kind of discouraged. So the thing I wanted to show you though with this is that when you pull an external branch, technically you have an option to do the merge, which is the default strategy. That's exactly what just happened. So when I pulled master into development, it low-key behind the scenes did a merge for me, which is the same thing as if I did git merge. If I was to do this the correct way, approved wise, it would have been git merge master, right? So I'm on development now, but I want to merge master into development. So I would have done git merge master. But now that that branch is updated, I have both of the copies that I want, right? This other points, rebase and fast forward only, are two other options for how you can tell Git to reconcile divergent branches, which basically says, how do I deal with branches that have two different things? And what do you want me to do if they have two different things? Merge basically pulls everything in one way. Rebase is another type of way to reconcile those changes. And then fast forward only is one more. Depending on what's going on in your repo, you might have different use cases for any of those three. But for me right now, really all I wanted to do was merge. So I got development updated with master. And I see that I got both of those repos or those readmes in there that allow me to know that that's the case. So last thing I want to show you is, say for instance, I am now working on a project, right? So one command that you can see is git branch. Will show you the branches that you have locally. So these branches are the branches I have access to or that I've seen already. There might be other branches, but if I don't know their names and I haven't checked out to them and they haven't been pulled from my last pull, I won't be able to change into them. But I have these branches that I want to work off of. And remember what I told you is that whenever you make a branch, you pull from that specific repo that you pull from that specific snapshot that you're looking at. So I'm already on development. So if I did git checkout -b again to create a new branch, and I said feature one, right? I created a new branch called feature one, and that branch was pulled off of development, right? So this branch now is updated with development, which right now is updated with master. But for the sake of this idea, I have a new branch pulled off of development. And on this branch, right, I might want to make some more changes. So maybe I make another README and say feature one.md, right? And just, put some text in there and say, this is from feature one branch. Oops, my fault. Okay. So now this branch is completely different, right? It has its own read, different files. And I might want to, whoops, didn't mean to make this thing. So I might want to, now that this branch is done, right? I might be ready and say, okay, cool. Let me add the changes, git commit -m, say added feature one readme, right? And I can push, remember this is a new branch, so I gotta do origin and then give this origin a specific branch to track. And so I'm just gonna keep it feature one for now. And cool, so Git is gonna add the feature one branch to my code on GitHub. So now I have a new branch called feature one on GitHub. But remember that feature one is completely different than main and then development. Development doesn't have any awareness of this feature one branch, and neither does main, right? Or master. So the important thing is to know, okay, I'm at a point where I have different divergent branches, right? All my branches are kind of different right now. So we saw one way of fixing that, which is using just the merge tool in the command line, which is definitely a way to commence a merge. But the pull request route is a more widely accepted way to start the merge process, because it gives your teammates another opportunity to look at your code, and it doesn't do the merge automatically. That's the big thing. When you just do the merge in the terminal, it automatically starts, and if you mess it up, it messes up, and you gotta just fix it. There's no real big harm, but it just, it's not as helpful as now, okay, I have feature one branch and I'm ready to make a change. I'm ready to push it into development, right? And in this case, that would be the example of maybe right now, well, this doesn't show this kind of significant example, but the idea is I have feature one and I want to push it back into development. And then other people from my team might be using development to do stuff. So to do this as a pull request, I create a new pull request. If I click on the new pull request button, and the new pull request button is going to take you to this screen that asks you, okay, what branches do you want to compare the changes from? So again, this syntax is a little funky, but think of it like this. One branch is going to push changes into another branch. So you're always going to want to follow that arrow in that sense. So in this case, the branch I want to take a look at is feature one, right? I want feature one, but I don't want to go directly into master. I'm just going to go in development, because development is a little bit more friendly for my team. I want them to be able to make changes before we actually put it back on the main branch. So we're going to use development branch as our kind of ground zero for our teamwork, instead of just pushing everything into main, which I'll talk about right after this. So clearly, this is saying compare feature one and with development. And it says, I have the ability to automatically merge this. So, that's great. If it's basically saying that if I were to do Git Merge from development with feature one, I would be able to merge the branches and it wouldn't give me any errors of like merge conflicts, which is cool. I still would have had to make a little commit like that Vim editor was showing me, but it would have merged the files just fine, and that would have been cool. But sometimes it's not able to merge it automatically. And that's when you get what I was talking to you about, a merge conflict, where like the files are a little bit messed up. So now that I've made this, I've started this process of creating this pull request, it's showing me what commits are going to be pushed in there, right? So clearly the last commit is this added feature one readme. And it's going to show me the files that I'm trying to edit. And it's saying, okay, I'm going to edit the feature one and the master readme file, right? And it's like, okay, cool. Are you ready? And I'm like, yeah, let me create this pull request. And then to create a pull request, I basically say, give it a title and say, adding feature one readme as an example. And I can leave a comment for my team and be like, I can add anyone on my team and be like, take a look at this and let me know if I can improve it in any way, right? So this is an opportunity for you to talk to your team and really get feedback. Or, hey, I'm having a problem with this repo. I might want to add some images so they can see what's going on and be like, hey, I'm seeing this error come up. And this is where collaboration on GitHub also turns into practical skills. So you can really start a conversation with people within the pull request window, as well as in the GitHub issues window, which is another area where you can talk to folks about problems that people are raising on the repo. So once I am ready to go, I can create the pull request, and the pull request is going to just get created. And now anyone that manages this repo or publicly can just go and see the pull requests that were made. And the pull requests are public by default, unless you're on a private repo. And now anyone on my team can go to this pull request, see my code that I am saying, hey, I want y'all to take a look at, right? And then can confirm. They can look through my files, take a look at my commits, all of that, and then basically say, okay, cool, let me see if I actually want to merge this. And once they are ready to merge it, then they can click this beautiful green button to merge the pull request and confirm that they think that this is a good merge. And then eventually the pull request actually gets merged. If they don't want to merge it immediately, they can send you back a thing and say something like, hey, you forgot, you forgot something, right? And then they can close your pull request and say, hey, they can either close it and say like, hey, you forgot something crucial, and they might be like, hey, you close it out and then let you know. Or they might just comment and let you know, hey, you might start a dialogue before they close it. So it's not often that they'll close it completely, unless like maybe there was somebody else did it already and they're like, hey, somebody else did this, so I'm gonna close this or something. But they have your manager has the option to do that, close it with a comment or just comment. And if they don't want to comment and they're like, yo, I like what you did, they'll just merge it. And they can also write a comment with the merge and say something like, great job, you know what I'm saying? And they can leave that comment and confirm the merge. And then boom, now this merge is created. So now my feature 1 branch changes are now in my development changes. And you can see it says, you can see it says that those merges were, you can see that those merges were made successfully. It says merge commit into development, right? Which is exactly what I wanted it to do. And now, now that it's done, I can, what was I gonna say? Pull request, oh yeah. So now that it's done, right? I had the option to, after making a commit, I have the option to delete that branch. I think I missed it because I clicked out of the window too soon. But normally what it does is after the commit is made, you have the option after you've merged to delete that branch that you're looking at. So sometimes people will create branches that they know are going to get deleted once the change is made. And that's what we call a feature branch. So that's why I named this branch feature, right? So because this feature branch is not one that I really need to have long-term. Once the changes are made and somebody merges it, they might be like, cool, Cam, great. I'm going to delete this now. Great job. And they delete the feature 1 branch, but development is still there and master or main is still there, because those branches are typically the branches that we keep along a project, because those branches represent 2 very important things for our project. The master branch represents our main history. So it's like the main history of our project over time. And typically we use that branch to keep the most up-to-date record of our history over time. So you wouldn't want to, well, let me rephrase this. The main and master branch is really useful for keeping commits of major milestones in the project. Let me say that. The development branch is normally a branch we create to just keep the most up-to-date record of the code. So you know how like when we install Git or when we installed Node, right? And we went to like Node, we went to like the Node website, and there was an option for us to download Node in a couple of different ways, right? On nodejs.org, it gives you the option to download the current version, latest version, and it had the most recommended version, right? You can think of this kind of like how you would think of the difference between a development branch and the master branch. The master branch probably is the last branch that has the most up-to-date testing. It's probably the branch that's deployed on the website now, but the development branch might be a little bit further along than the main branch because people are currently doing changes on it right now. So that's why we normally create multiple branches, right? To just keep a record of our main history, keep a record of a history that's going to be relevant to us in a consistently updated sense, and then maybe doing features and stuff. And we end up merging those branches over time, and all of that is useful for this process of collaborating with other engineers over the course of our work. And yeah, so That's kind of a deep dive intro to like collaborating using Git and GitHub. And again, you know, you're always going to run into some errors here and there while you're getting used to it. It takes some time and keep working on projects to kind of learn what needs to go on. But at the end of the day, you know, this is like a big rite of passage for y'all if you're watching this to like get into collaboration as engineers. And it also goes into the point of like what GitHub is really built for, which is not only for you to just save your repos online, but for you to like literally like connect with other people who are building unique things and to support them, right? So if you see like projects that you care about, or you see like people working on unique things that are really interesting, GitHub is literally one of the biggest tools for open source development, right? So you find open source projects that people are working on that you're like, yo, I want to support this. And in that project, you'd be able to collaborate with them in a very unique way. So I think on the in GitHub, let's see. Just to show you this last thing, and then we good. Is just trying to get an example. So let's see, web audio, blah 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 blah. Cool. So there's a lot of repos on here, right? And so say for instance, I'm excited about supporting this project, Melon.js, right? A fresh and lightweight JavaScript game engine. Maybe this is something I care about, right? I'm not a collaborator on this project. There's somebody else owns this project. Well, that's where the idea of collaboration comes up in a different sense. If you're not an owner of a repo, but you want to collaborate, you can always create a pull request to a main repo by using what's called a fork. So a fork is like you basically creating your own version of a repo that is going to be custom to you. So now you can see I created a new repo called Melon.js that's forked from the main Melon.js web repo. And so GitHub creates one that's uniquely my copy of the repo, right? So I can do what I told y'all before. Now that I have that copy, I can clone it onto my local machine, make my changes, and then when I'm ready, I can push those changes to my own branch master or wherever I want to create my own. I can do whatever I want because this is my version of the Melon.js website or Melon.js repo, excuse me. And so when I'm really ready to go ahead and make to say, hey, I want y'all to take a look at this, I can make a pull request and then say, cool, like I want to take my version of Melon.js and compare it with the original version and then make a pull request with my changes. And that's how people contribute to open source. That's literally what the process is. It's like, I get a copy of the repo, make the changes I want to make, and then send it off as a pull request. And then basically on the Melon.js repo, right? They're getting notifications of pull requests that people are trying to make. And clearly they had 230 pull requests that people made that then they closed over time, right? And so that's how people are connecting and collaborating over open source and using Git and GitHub as a tool. It's a really cool way to get involved. I've heard really great stories of folks being like, yo, like for a project, I found a project online for a company I wanted to get a job at, and I made an open source commit, and people from the recruiting team hit me up because they saw that I made those commits and they were accepted into the repo. That's like one of the best ways to get a job in terms of showing yourself as you can do the work, right? It's just, hey, I made some changes to the repo. You should take a look and accept the pull request or whatnot. So yeah, that is my long-winded rant on the utility of Git and GitHub in the collaboration process. Appreciate you for listening, and yeah, I'll take any questions that folks have on